University, New Delhi. Please join me in welcoming Sir. Dr. Anup Kumar Sir is an accomplished academician and researcher with a distinguished career in pharmacology. He holds a PhD in pharmacology and has previously contributed to teaching and leadership roles at premier institutes such as Naiper Mohali. He has authored over 200 peer-reviewed publications in reputed journals, reflecting his extensive contributions to drug discovery, safety, and healthcare decision-making. His research expertise include drug repurposing through computational in vitro, in vivo, and network pharmacological approaches, pharmacoeconomics, systematic reviews, and meta-analysis, pharmacovigilance with a special focus on signal detection, drug safety, and adverse reaction monitoring. SIR is recognized as a tough leader in emerging areas such as computational drug discovery, data-driven safety surveillance systems, and pharmacoeconomic evaluations, which play a pivotal role in shaping evidence-based therapeutic practices. With his dedication to advancing pharmacological sciences and improving patient safety, Sir continues to inspire as a researcher, mentor, and invocator. Welcome, Sir. Now the virtual stage is
Thank you.
yours.
Yeah, thank you so much for kind introductions. And thank you to RX Dr. Farm D Form. And congratulations for conducting such a nice conference. I hope my slides are visible and I hope I am audible too, right?
Yes, very audible.
Yeah, great. So for next about 20-25 to 30 minutes, I am going to give you overview about meta-analysis tool. What if someone of you would like to do SLR and meta-analysis, so how you can do it. So just this is just a disclaimer. I am just skipping that part. So what I am going to cover is what actually the meta-analysis is, how to develop a protocol for the meta-analysis, and how to do the registrations of the protocol, how to uh, reframe the search strategies, how to do the quality assessment, how to extract the data and analyze the data, and little bit about the grade analysis and AI-based tool as well, followed by the conclusion. So, so if any one of you want to become a SLR and meta-analysis expert, as many of you are from clinical pharmacology background or PharmD background or pharmacy practice background, so what skills are required? So I always say to the students, you should have a basic understanding of the research design and data. If you are not able to understand the data, you can't do the analysis, right? So meta-analysis is a statistical analysis of the already available data in the literature. So you should have a basic understanding of the research design. You should have a basic understandings upon the biostatistics. Like you should not be confused between SD, standard error of mean, parametric test, non-parametric test, normal distributions of the data and so on. So basic biostatistics knowledge is required. You should able to understand what is the risk ratio, what is odd ratio, what is the hazard ratios, what is mean difference, standard mean difference, and so on. And another thing which is required, skill is required, is identifications of the studies in various databases and data extraction. So you should have the ability to screen out the studies in various databases and how to extract the data. And technical skill which is required is, so if you are, you can means by for the meta analysis we are using various software. So one of the popular one is R package, and so R package little bit command based, but it's very easy to use. So I always recommend R because it's freely available. Any one of you can use it from your laptop as well. So again, another thing is talent is not enough. You need discipline, you need dedications, you need characters. And more people have failed not for the lack of talent but lack of character. So that also play important when you are going for an interview. You have all these things, but so at last you are not selected. So what are the reason for not you are not getting selected? The biostatistics, you have a technical skill, you have a good communication skill, and so on, everything you have, but you are at the end, you are if you are not selected, so what things are lacking? So that is your your discipline, your characters, your attitude. So it also plays significant roles when you are going for an interview, so you have to take care of that part as well. So coming to the topic, meta-analysis. So meta-analysis is particularly provide the clarity among the published studies. It's a quantitative approach, as I said. It's a means you are doing the analysis and analysis. To do the analysis, you should have a data. So it's a quantitative. So it's a quantitative approach for systematically combining the result of previous research to arrive at conclusion about the body of research. So we are doing the calculating the overall estimate, and then we are try to make up the conclusion out of it. It's just like a, you can see in this picture, you have put it the net in the ocean. So ocean is your literature. If you see, there is lot of papers are there available in various databases. So it's just like a oceans. You have put it your net. Net is your search strategies which you have make according to your aim and objective of the studies. You can't do all the literature, all the things screening parts. You have to be, you want only those studies which fit as per your aim and objective. So first thing, you have to define your aim and objective of the study, what you want to do, and accordingly you have to put the net, and net is your search strategies which you have to make according to your aim and objective. So you want particular pieces. So when you collect the faces, so after collection of the faces, what you have to do, you are going you are doing the segregation of the faces. Maybe some one of you some faces are of not of good quality, some are of very good quality, some are excellent, some are poor qualities. So you are doing the segregation. So similar way we are also doing in the meta analysis. Before doing the meta analysis, we have to do the SLR, systematic literature review, and in systematic literature review we have to do the search in the various databases, and after that you are getting lot of literature. So you have to do the quality assessment of those literature as well. Maybe some studies are of poor quality, some studies are of good, some studies are excellent quality. So it's always advisable, you have to exclude if there is a poor quality studies are there, right? So if you see this circle, so you can understand better that what is the difference between SLR and meta-analysis. So bigger circle is SLR and smaller circle is meta-analysis. So it's obviously means that every meta-analysis should have the SLR. So you can't do the meta-analysis without the SLR. But every SLR may or may not be converted into meta-analysis. It depends upon what kind of data you are getting out of, from the literature. So sometimes students are very passionate to do the meta analysis on particular topic, and later on they came to know that, or their guide has told to them that it's not possible to do the meta analysis. You restrict your research up to SLR. SLR also you can publish in an international good journal of the repute as well. But it does not means that each and everything you will do the meta analysis. No, it depends upon what kind of data you are getting, how many studies you are getting, what what was the percentage of heterogeneity. If you are getting a lot of heterogeneity, publication bias is too high. So always there is a question on your meta analysis. Clinician will not accept your results. They will always put the questions, because there is a 100% heterogeneity, there is a publication bias, whatever the study you have taken that is of not good qualities. So you can't make a valid clinical decisions out of it. So if you see the health research pyramid, so you can see that we are doing animal studies, laboratory studies, then we are generating the evidence through case report, case series, then cross-sectional studies, then case controls, that is your retrospective studies, cohort studies, then RCTs, and you can see up there is a meta-analysis and systematic review. And based on these meta-analysis and systematic review, now policy makers are making the decision and to make framing the guidelines for particular disease. Like ICMR is recently framing a guidelines for the use of antibiotics in India, and they have given funding to various researchers who are working in the area of systematic review and meta-analysis. Our lab also got the funding to do the SLR meta-analysis to provide the evidence regarding use of antibiotics in the India, to set up the guidelines with respect to that. So you can see that these clinical practices guidelines, you can these meta-analysis and systematic review play a significant role in these guidelines. But of course, whenever you are putting your so you are providing your results for the clinical practice guidelines, so you have to do your steps, all the analysis in standardized way, right? So when it required, so sometimes sir, you come up with any topic and you are saying that, sir, I want to check the for examples for example atorvastatin, effect of atorvastatin on lipid profile. So is it a good topic to do the meta-analysis? No, it's not a good topic. Because it's already known. We have a sufficient evidence which indicate that statins are going to reduce your blood cholesterol level. If you want to check the effect of aspirin on MI patients, whether aspirin is going to reduce the mortality of MI patients or not, it's already known. We have means clear cut data, clear clinical data which indicate that it's working. So now question is, when you are selecting a topic, you have to be very careful. So you have to pick up such kind of topic where there is a confusion among the physicians, confusion among the doctors fraternities, where they one set of studies are saying that particular intervention is effective. Because I am pharmacologist, so I talk about interventions, but meta analysis you can do for other without interventions as well. So so when there is a confusions, that some set of studies are saying it's effective, some set of studies are saying it's not that much effective, some studies are saying it's it's going to result in various adverse drug reactions. So ultimately physicians are also confused. They don't they are not able to make a clear cut decisions on that particular medicines. So such kind of topics you can pick up for the meta analysis, and that can help. Okay, that can help the clinicians to make a better clinical decisions out of it, right? So we are particularly picking such kind of topic which are controversial, which are there is a confusions for SLR and meta analysis. So if you have pick up the topic, so first thing which you have to do is you have to be develop a protocol. I have seen many students what they are doing. They are in the mid of their meta-analysis or SLR. Now they are writing. They are asking, sir, can we do the registration of protocol? No, you can't do in the mid of your project. First step, after designing, after picking up the topic, first step you have to write the protocol on that, and that protocol development, and then you have to be submitted for the registrations, and then you start your work. So that is the thumb rule. That is, otherwise your protocol will not registered. Like in Prosperos, you have to put, Prospero will ask you when you have started this study, what is completions, expected completion date. So if you are putting that you have already done the screening, now you are going for a protocol registration, it will it will not accepted that part. So protocol development, in protocol you have to mention each and everything. So you should clear about your objective, you should clear about eligibility criteria, inclusion, which studies you would like to going to include, or which studies you would like to exclude. And normally in meta analysis we are excluding the already published systematic review, narrative review, case reports, case series, these all kind of study, and already published meta-analysis, these all kind of studies we are going to exclude. But again, it depends upon your aim and objective, and then you have to mention about how you are going to search various databases for these research questions, how you are going to do the quality assessment, what method you are going to use for the analysis. So all these things you have to mention in your protocol. And you have to be also mentions if there will be a heterogeneity among the studies, so how you are going to address, whether you are going for a meta regressions, whether you are going for a subgroup analysis, how you are going to address if you are getting a high heterogeneity, and what factors could affect the result of studies. So each and everything you have to mention in your protocol, and then you have to go for a registrations. One of the popular one is, you might have seen in various meta-analysis which are already published at international platform, is Prospero. So in Prospero, you can join the Prospero. It's freely available. You just create your login ID and passwords. So this is a screenshot of Prospero. This is a international prospective register of systematic review, and then you can see that after login you can click on register your review now. So now it will ask you the questions, when whether you are going to a systematic review with respect to human. You can do with animal as well if you are working in a preclinical area. So you can and you want to do some meta analysis, in that case you can use that part as well. So you can see that these type of questions Prosperos will ask, will your registration record be in English? If you are putting no, it's not going to register. Is this scoping? Hello? So scoping review, mapping review is also not going to register. So all these questions you have to put yes, no, and then you have to put the detailed protocol in these options. You can see that review titles, anticipated start date, anticipated completion date, all keywords, design, current review status, each and everything. So these are the protocol, some of the protocol which our lab have registered with the Prosperos. So you will get this number like this after registrations, and these numbers in your manuscript you can mention that the protocol of your study is registered with Prospero with this number, so that you can mention in that one. Other register with respect to registration of the protocol is Open Science Framework, that is the OSF. That will do the registration quickly, whereas Prospero taking time. But now I think last month or 1 or 2 months back, Prospero is also not taking that much time. But earlier it taking a lot of time to for the registrations. So others framework are OSF in Classy is there, and with respect to ICMR, also have given the notifications regarding, because there might be a little bit of confusion among systematic review and meta-analysis researcher, that whether we have to be get the ethical approval, because we are using the human data for the analysis, right? So the ICMR has given notification, and in that one they have mentioned that there is no need to, if you are following the standard guidelines, there is no need to get the ethical approvals. But if you are not following the standard guidelines or Prospero, then you have to submit to the ethics committee. So you can see that they have clearly mentioned, if you are doing a systematic review meta-analysis protocol, and if your protocol is following the standard guidelines and procedures and doing the registrations in these type of registers, so it does not require submission to ethics committee for the clearance. So it's clearly mentions there is no need to if you are following the standard guidelines, right? So important points with respect to systematic review and meta-analysis is you have to involve a team to do the meta-analysis, but unnecessary team is also not required, because each and every one task has to be defined. Because in meta-analysis you need at least two researcher who will do the screening of the study independently, and it's mentioned in the guidelines, right? So you need two researcher. Third one, reviewer is required who will resolve disagreement among both of the authors, right? Both of the researchers. So all these, and if you are working in particular area, it's better to involve a clinician as well to get the expert comments on your data entry form or all these aspect as well. So what are the steps in the meta-analysis if you want to do meta-analysis? So first you have to formulate your research questions in the PICO format. PICO, P stands for the population or the patients. You have to define your interventions, you have to define your comparator, and O is you have to define your outcome. For example, you want to see what is the role of aspirin in the mortality of COVID-19 patients. So in that case, your population or patient is COVID-19 patients. Intervention is your aspirin. Comparator is your non-aspirin group. Outcome is your death. So like that, you have to be define your research questions into the PICO format. There is a PICO S as well, which talk about study design. There is a T as well, that is a time frame as well. So step two is you have to be define your eligibility criteria inclusion, which studies you want to keep and which studies you want to throw out, and then you have to do the quality assessment of the studies, and then you have to extract the data in the data extraction state, and then you have to apply the statistical methods, and you can do subgroup and sensitivity analysis. So first step is identification of the studies. Maybe many of you are already knows about PubMed, Medline, Embase. So all these you have to use. You have to be put your medical subject heading with the proper Boolean operator. So in the so if you, for example, you want to know the efficacy and safety of gapirone in the treatment of MDD, so you can put the search strategies with the Boolean operators gapirone and MDD. So it will catch all those articles where gapirone is tested in the MDD. But if you are using the incorrect Boolean operator, so you will get a lot of uh, uh, a lot of literatures which is maybe irrelevant to you. So in PubMed, I hope many of you knows that you have to click on the advanced, and in advanced you can see that there is a query box. You can put here are the Boolean operator, here are the mesh terms. So you can keep that, and in left hand side there is also number of filters are there. So you can filters, you can click on RCT as well if you want to collect the data from the RCT only, because RCTs are gold standard. So if you are doing the meta-analysis of RCTs, so your acceptance will be more as compared to if you are taking all types of studies. So question will be arise on you why you have taken different design of the studies. If you are going to include, so you have to be analyze them separately as well. So all these filter you can put, and so these are the filters where you can see that free full text as well. You can put the time filter as well, and you have to be custom range. You have to mention the end date as well, because in your studies you have to mention up to what date you are going to include your data. So so first you have to do the screening based on the title, then based on the abstract. So abstract file you can generate, you can click on the format, select the abstract and create file. So your abstract file of those article which you feel important according to your title of the studies, it will, or abstract file will be automatically created. The eligibility of the studies, again, it depends upon your research questions, but of course case series, case report, already published review articles, we are normally excluding from the meta analysis. So these are the various critical appraisals, quality assessment tool. Depending upon the study designs, we have a quality assessment. There is NIH quality assessment tool separate for the case control study, cohort study separate for RCTs, and these every articles you have to be assessed for the quality assessment as well. And you have to follow the Prisma guideline. Prisma is preferred reporting item for systematic review and meta-analysis. It's published in first published in 2009, but recent one is 2020. So you have to follow this 2020. And Prisma is providing the checklist as well as the flow diagram. So you can see that this is the checklist screenshot. So where you have to fill this checklist when you are going to do this SLR and meta-analysis. And many students, what they are doing, they are creating this flow chart by themselves in Paint or in Word file. There is no need to create. Go to the Prisma websites, and there you can download this flow chart, and you can see that n is equal to, here you have to put your numbers and whatever the number. So you have to do the identifications, then you have to do the screening, then you are going to include finally articles which are relevant for your aim and objective. And then you have to go through the full text of those articles and put your data into data extraction sheet. So data extraction sheet column will again depend upon your research questions, and these data extraction sheet you have to validate with the experts as well when you are working on it, because it's important. And then you have to do the analysis of data. So data we are mainly categorizing into two types: dichotomous data and continuous data. For dichotomous data, the overall estimate, we have a two options: odd ratios and relative risk. And for continuous data, we can calculate the overall estimate in terms of MD, that is the mean difference, or SMD, that is the standard mean difference. So odd ratio we are going when outcome is mortality or death, whereas we are going with the other with the relative risk. MD we are going with the continuous data. SMD we are going with if outcome is measured in two different scales, or different scales are used to measure the same outcomes, we are going with the SMD instead of MD. And then we are putting with the 95% confidence interval, and for two plot you will oftenly see in the meta-analysis: forest plot and funnel plot. So this is just a slide, forest plot. So if you see the forest closely, you will find that there is a similarity between the forest plot and the forest. So in forest is made up of tree. If you see closely the tree, there is a main stem and there are branches. So if you see the forest plot, there is also a main tree. This is the main vertical line, and along the vertical line there is a branches. So this vertical line is the null effect, where if your diamond is touching with the null line, so your results will be non-significant. These horizontal line is representing the confidence interval. This is a study one, and this line is representing the confidence intervals, and this square box is representing the weightage to the study. So weightage is given according to the sample size of the studies. So this is horizontal line is representing confidential interval of this particular studies, and this is second one, this is the third one. So in meta-analysis, particularly forest plot, if you want to read, you have to look for this diamond. Diamond is providing you the overall estimates of all the studies. So you have to look for the diamond, and this is the diamond, and this is here they have calculated the risk ratios, and they have used the fixed effect model. There are two types of models. Fixed effect models we are using when variation among the study is less. Otherwise, we will go with the random effect model. So this is the 0.64. This is the confidence interval 0.36 to 1.15. Although your 0.64 is fall within the confidence intervals, but conclusions in this case is non-significant. Why it's a non-significant? Because your upper level of confidence interval is 1.15 and 1.15, and if you see this diamond closely, this diamond one part is touching your vertical line, and this is the null effect. So that's why, of course, there is a differences, but differences is not a significant, it's non-significant difference. That is a conclusion. So that you have to read the forest plot, and you have to look for the heterogeneity. Heterogeneity I square value is providing, so it's a 0%. Heterogeneity is chi-squares. There is a Cochrane Q test as well, but it will not tell you about how much heterogeneity. It will tell you about with respect to p values whether heterogeneity is significant or non-significant. So it's a non-significant heterogeneity because your p value is 0.99, right? So funnel plot, if you see another plot, this is just like a funnel. So what actually it is? So so when you are putting your overall estimate with the standard error, this dot is representing the single studies. If your funnel is not symmetrical, so your conclusion is there is a involvement of publication bias. So funnel plot is just tell you about the qualitative assessment of the publication bias. By looking the funnel plot, or you can only say that whether there is a publication bias or not. That's it. You can't say that the publication bias is significant or non-significant. You can't say that. For that one, you have to apply further test, that is the Bagger and Eager test. By that will from where you will get the p-value, and you can conclude that whether this publication bias is significant or non-significant. But by looking at the funnel, you can only see that if your funnel is symmetrical, your conclusion is there is a less involvement of publication bias, right? So weightage of study, I already told, small sample size provide the less weightage, large sample size you will get the high weightage. And selection of model, I already told you, if variation among studies is high, you will go with the random, otherwise you will go with the fixed effect model. Due to lack of time, I am not going to explain what is the hypothesis behind your random and fixed effect model, and how selection of model influence the overall effect size. So if you see, this is the same data, I have just change the model. Here fixed effect model is used, and here random effect model is used. So you can see the differences. Here I am getting the overall estimate is 0.45, and this is a confidence interval. Here I am getting 0.38. So and heterogeneity is high, so I have to go with the random effect model rather than fixed effect model. Otherwise you can see the differences. Heterogeneity, I already explained. Heterogeneity can be in terms of clinical differences in the participants, because you are pulling data from the different studies, so it can heterogeneity is obvious. So how to identify and measure the heterogeneity? There is a eyeball test, chi-square test. As I said, it will provide you the p values. So low p values indicate heterogeneity among the studies. I square will give you the quantitative numbers, and these are the quantitative number, like in this case 51%. And if you are getting lot of heterogeneity, so first thing is you have to cross check for the mistakes, and you have to look for the typographical error. Sometimes when you are entering the data in the softwares, or in the data extraction sheet, maybe that is 10.23, and you have put it 1 0 extra, and that 0 extra will be provide you a lot of heterogeneity. So you have to cross check for your data for any typographical error. But if still there is a heterogeneity is high, so you have to do the meta regressions. Publication bias, I already told you. This is Bagger and Eager. Bagger we are using for the smaller numbers, Eager we are applying for the larger number. So how to handle? We have to be search for the unpublished result, and should not be limited to the study published in English language only. So that's why we always say that you have to be explore. You have to search all the available databases, right? If there is any important article is there, you don't want to miss any articles. All search engines. And subgroup and sensitivity analysis, you can do it depending upon your data. You can check the effect of variables on outcome as well. And nowadays, a lot of student or researcher are using AI-based tool as well to speed up the screening process of the articles. So this is the Elicit. Elicit is the one of the AI-based tool where you can analyze research papers. Basic is there is freely available. For the subscriptions, you can use it. So here you can. These are the screenshot how to use it. I'm not going in that much detail. AI for research is another one. Meet your intelligent, that is genuine, is another AI. And Lit Suggest is another one which will provide you the similar studies based on your research interest, based on machine learning. Lit Map is another one important tool where you can get you can identify the studies. And screening of articles you can do by digital R, which many CROs or companies are using. It's commercially available, but for academics, you can use the Rian free version. So Rian is very popular now. Day by day, it's becoming popular, where you can do the blinding, where you can import the studies, where you can put the comments. Third reviewer can see, you can blind the two independent authors, each others, and third one can see the progress and each and everything. You can put the comments as well. So Rian is another one. Laser AI, there is a risk of bias tools are there, ROB tools. But again, due to shortage of time, I am not going in detail. So you can do fill these. And softwares, as I said, Rabman is there, but so I would recommend use the R package. And grade is after meta-analysis. Grade is something. It's a systematic approach to rating the certainty of evidence in a systematic review and other evidence. So if you are trying to put your meta-analysis result for evidence-based guidelines, so they will always ask you for the grade analysis. So it's a grade of recommendation, assessment, development, and evaluation. So depending upon your what analysis you have done, how quality studies you have included, all these factors will be provide the grade to your meta-analysis. Like in school, you are getting in college, you are getting grade A plus A, B, C, like that, right? So it's a grading of the recommendation, and we are giving based on the randomizations, concealment of allocation, random sequence, and risk of bias. So if you are getting high grade 0.4, so further research is not required. You can give the recommendations. Moderate 0.3 may change. If you are getting 0.2 very likely, and 0.1 very certain. So grade pro is the one of the popular softwares which you can use for the grade analysis. So just conclusion is meta-analysis help to make a better clinical decision, particularly in the complex issues. But SLR is must, and but you have to plan these studies in a better way. And as I said, it's always recommended to involve a group of experts to conduct this type of analysis in a proper way. You can see that even in Lancet, JAMAs, NEJM are publishing the meta-analysis. But if you see the quality of their meta-analysis, you will find that it takes a lot of time and a lot of experts as well. So these are the recent publications. Uh, sorry. From our lab with respect to meta-analysis, which we have done so far. These ACH Chemical Neuroscience, International Journal of Clinical Practices, Health Sciences Review, European Journal of Pharmacology. We have done these meta-analysis, and this is one of the book which I have authored on meta-analysis in clinical research, principle and procedures. This contains each and every steps by if you are planning to use the Rebman screenshots are also included step by step. And this is another book, but this is not relevant to this particular lectures, but this is the another book which is signal analysis in pharmacovigilance principle and processes. So I would to and acknowledge all the institutions where I have worked. And another one is R package. I told you this R is being used popularly for the meta analysis, so you can install the R in your laptop. So this is the CRAN websites. You can go through it, download it. These are the simple to install. It will open like this, but to use it, you have to install RStudio as well. Install that one as well, and then you can put the command in the RStudios. So to put the command in the RStudios, first commands you can use the install.packages. So for the meta, package name is meta. Then you can do the so loading of that package. Then you can import the data. For the import the data, this is your so like that there are commands by which you can generate your forest plot, funnel plot, each and everything. So these are the commands. So thank you so much. I hope I have not taken much more time. So thanks to S by CON S6 and congratulations for conducting international conference on such a important topic. Thank you so much. If you have any questions, you can put your queries on this email ID, or you can reach me as well. Thank you so much. Yeah. Any questions? I love to take if there is any questions from anyone. Can I see the chat box? Okay. Yes. Any questions? You can unmute and ask if there is any questions from your side. I can understand it's too fast, but I just give you the glimpse about SLR and meta-analysis. If anyone of you already working, so they will understand better. But of course, if you are new to this discipline, so you can explore it. Means about the SLR and meta-analysis. And being from these backgrounds, we can do a lot of. And the beauty of these SLR meta, you are not dependent on any other things. You should have a computers. You should have a access to you can do by using the freely available databases where you can get the research studies. So that you can do. R is freely available, so you can use it, you can install it, and by R you can do a lot of other analysis as well. It's not only for meta. R contains a lot of other packages as well. But if you want to do Meta, so there is a Meta package is there. You can do the installations. You can import the Excel file in the R, and then you can apply the for the dichotomous data. You can use the MetaWin and meta count for your continuous data, and you can generate your forest plot, funnel plot as well. Okay. Yes. Anything else? Hello. I hope I am audible. Can anyone unmute?
Yes, sir, you're audible.
Yeah, great. So, any questions from anyone? Actually, I am traveling, so I am not means giving that much time. But of course, I have given my email IDs. If you have any questions, anything, you can put email to me directly. There is no issue. Okay. Any quick questions from anyone? They can unmute and ask. No issue. With respect to SLR, meta, grade. Okay. Okay, no issue. So thank you so much for joining and for your participations in such a useful conference. Thank you so much. Have a wonderful day. Right. Yeah, over to you.
Kumar, sir, for your insightful and engaging presentation. Your expertise in pharmacology and research has greatly enriched our understanding, especially on the critical aspects of exploring meta-analysis tool. We are truly value the knowledge you shared with us today, sir, and sincerely appreciate your time and contribution to this session. Thank you once again, sir, for joining with us in SYCCON at 6 day 17.
Thank you so much. Thank you. Thank you very much. Have a nice day. Thank you.